Class 11th chemistry, we were discussing unit 13 hydrocarbons, and in this video we will discuss about mechanism of electrophilic substitution reactions. According to experimental evidence says SE means S for substitution and E for electrophilic. It means electrophilic substitution reactions are supposed to proceed via the following three steps. First one is generation of the electrophile. Second step is formation of carbocation intermediate, and third step is removal of proton from the carbocation intermediate. Now first step is generation of electrophile, that is E positive charge. In the previous video we have discussed about the different electrophilic substitution reaction of benzene like nitration, chlorination, sulfonation, Friedel-Crafts alkylation, Friedel-Crafts acylation. Now we will discuss what are the electrophiles in these reactions. In case of nitration, electrophile is nitronium ion, NO2 positive charge. Chlorination, electrophile is chloronium ion, Cl positive charge. Friedel-Crafts alkylation, electrophile is carbocation, that is R positive charge. Friedel-Crafts acylation, electrophile is acylium ion, this is RCO, and on carbon positive charge is there. Okay. Now see how these electrophiles are generated. First discuss the nitration. The electrophile nitronium ion is produced by transfer of a proton from sulfuric acid to nitric acid. Just see the reaction. This is sulfuric acid. As we know, the formula of sulfuric acid is H2SO4. Okay, and formula of nitric acid is HNO3. And this H2SO4 can be written like this. And this is HNO3. Now what happens in this? This bond will break down, or we can say this is H plus will release from H2SO4. Okay, and this H plus will accepted by this nitric acid to this oxygen. So we will get HSO4 minus and we will get this protonated nitric acid. Okay, now in this reaction, sulfuric acid serves as an acid because it donates the proton, and as per the Bronsted concept of acid and base, proton donors are acids. So in this case, sulfuric acid is acting as a acid, Bronsted acid, and nitric acid is accepting that proton. That's why this serves as a base. Okay, so this is a simple acid base equilibrium. And then in the step 2, this protonated nitric acid give this nitronium ion NO2 plus along with the water. This nitronium ion will attack on the benzene ring. Clear? Now in case of chlorination, this Cl2 molecule and AlCl3 is act as a Lewis acid, and this is a catalyst. So in the presence of AlCl3, this bond will break down. Okay, and chloronium ion is produced, which is electrophile in chlorination along with the formation of AlCl4 minus ion. The same way in case of Friedel-Crafts alkylation. Okay, this is CH3Cl methyl chloride. This is AlCl3. Okay, in the presence of Lewis acid, again this bond will break down and CH3, that is methyl cation, is produced, which act as a electrophile, and AlCl4 minus is formed. In the same case, in case of Friedel-Crafts acylation, this is CH3COCl acetyl chloride. When in the presence of AlCl3, we will get the acylinium ion. This bond will break. Okay, and we will get this is CH3CO positive charge along with the AlCl4 minus. This is the first step, generation of electrophile. Now in the second step, formation of carbocation. This carbocation is also known as arenium ion. Attack of electrophile results in the formation of sigma complex or arenium ion, in which one of the carbon is sp3 hybridized. Now see, this is benzene ring, this is electrophile. Now in the presence of electrophile, the pi electron of one of the double bond will shift, okay, will translocate. सो आप कह सकते हैं इलेक्ट्रोफाइल की प्रेजेंस में यदि ये पाई बॉन्ड के इलेक्ट्रॉन इस वाले कार्बन पे जाते हैं, इस कार्बन पे, तो इस पे कार्बन आप कह सकते हैं it becomes negatively charged, so this E electrophile will attack on this carbon, okay, and this carbon will acquire the positive charge. So this carbon becomes sp3 hybridized carbon, and this complex is known as sigma complex or arenium ion. Now in sigma complex or arenium ion, it loses its aromatic character because delocalization of electrons stops at sp3 hybridized carbon, and this arenium ion gets stabilized by resonance. See, this is the resonance in arenium ion. यहां से पाई इलेक्ट्रॉन यहां पर शिफ्ट होंगे तो पॉजिटिव चार्ज इस वाले कार्बन पर आ जाएगा, दिस वन, और फिर यहां से ये पाई इलेक्ट्रॉन यहां पर शिफ्ट होंगे तो पॉजिटिव चार्ज इस वाले कार्बन पर आ जाएगा, लाइक दिस. तो दिस इज रेजोनेंस हाइब्रिड. इसमें आप देख सकते हैं इस वाले कार्बन पर ये पाई इलेक्ट्रॉन डी लोकलाइज नहीं हो रहे हैं बिकॉज दिस इज sp3 हाइब्रिडाइज्ड. सो दिस एरेनियम आयन डज नॉट कंटेन एरोमेटिक कैरेक्टर. क्लियर? नाउ लास्ट स्टेप, रिमूवल ऑफ प्रोटॉन. To restore the aromatic character, sigma complex releases proton from sp3 hybridized carbon on attack by AlCl4- in case of halogenation, alkylation and acylation, and HSO4- in case of nitration. So this is sigma complex, and in case of halogenation, alkylation and acylation, this AlCl4- is there. So आप कह सकते हैं कि ये इस जो sp3 हाइब्रिडाइज्ड कार्बन है उस पे जो हाइड्रोजन जुड़ा हुआ है, तो इस कार्बन और इस हाइड्रोजन की जो बॉन्ड है ये बॉन्ड यहाँ पर शिफ्ट होंगे और दिस H इज रिलीज्ड, ओके, एंड वी विल गेट दिस फाइनल प्रोडक्ट. ओके, यहाँ पर E क्या क्या हो सकता है? यदि हेलोजिनेशन है तो हेलोजन होगा X, क्लोरिनेशन करवा रहे हैं तो स्पेसिफाई Cl लिख सकते हैं. एल्काइलेशन में यदि एल्काइल ग्रुप CH3 है तो E में भी CH3. एसाइलेशन में यदि एसाइल ग्रुप हमारे पास एसिटाइल आ रहा है, इट में भी CH3CO. क्लियर? इन केस ऑफ नाइट्रेशन, दिस HSO4- गेन दिस H+, so this will convert into H2SO4, और यहाँ पर जो E आया है, this E is NO2. We will get the nitrobenzene. Okay, thank you.